Hi, this is a demo of my behavior tree editor built in Unity. So here we have a scene of a guy and he gets hungry. But fortunately for him, he's got some pancakes littered around the world. So how is he going to eat those pancakes? How do we make him do that? One way is to use a behavior tree. And here we have this behavior tree editor that I made. Um, so the first thing we can do, eating food is an action. So let's add an action node. And I made a quick script that says, okay, let's eat some food. And if we link that to the root node sends ticks, okay? Sends ticks to its children, and then its children decide how to deal with those ticks. So an action node, for example, will only execute if it receives a tick. So this is going to receive a tick from the root, and then the agent will perform this action. Okay, so let's save that. Okay, and we'll run this, and then we'll load the tree into the agent. Okay, so it's done. Oh, that's weird. Agent ate some food is false. So why is that happening? So the thing is about this agent, he only knows so much about the world. So he knows about his hunger, his decrease rate, and then the food that's nearby. So if we want, we can take this pancake here, that's close to him. Oops. Take this pancake that's near to him. We can input into there. Nearby food. So now when we do this here, we load the tree. Great. He ate the food. Our hunger went up. And yeah, that's exactly what we want it to happen. But what if we didn't want to drag that in here every time? So why don't we take that out, and then we're going to add that. Okay, we still want our eat food function. Okay, but now we want some kind of functionality to find food. So let's add another action, and I have a script here called find food, which will find the food that's nearest to the agent. Okay. So now we can add. We want these actions to perform one after another. So we want find food to happen, and then after that is successful, we want eat food to run. So we have a sequence node. That's exactly what we want. It's going to execute its children from the first one to the last one. If the first one fails, it won't execute the last one. It won't bother. But if the first one succeeds, it'll execute the next one. And you can have that for as many nodes as you want. So we'll connect those up there. So we'll do this, and we'll connect that to the root. We'll save it. So now you can see here, nearby food is none. He doesn't know about any food there. So hopefully, if this does what we want it to, he'll find that food. So we'll load it. Okay, he found it immediately and he ate it right away. Great. So what if we don't want him to eat it all the time? Like, what if we only want him to eat it when he's hungry? So we can add another action for that. So this is kind of a condition node. What's known as a condition node, but we have it just implemented as an action, just for simplicity. So now if he's hungry, we can make him do the rest of the actions. So remember, if we have our sequence here, if the first one fails, the rest of them won't run. It won't bother. So if he's not hungry, he won't go to our, even think about going to our goal state, which is eat food. So this could be the last thing in our tree. So now, okay, we want him to find food, right? So we'll create an action, find food. What if this action here is super costly? It takes a long time. There's a huge world, and it might take, you know, it's too expensive for us to run. So if we already have food here, it's probably not a good idea to check for more. So we can add what's called a fallback node. A fallback node, okay, this will take the first thing that succeeds and it'll continue with execution. It's kind of like an OR statement. So if this or this succeed, then we'll continue. So we want another action. This is going to be another condition actually. So if we know about some food, there's food nearby that we know about. We can continue on. We'll link these up here. And then we'll link these up here. Okay, so it'll check first. Okay, is there food nearby? If there's food nearby, we can continue on. If there's not food nearby, it's going to check the second one. Okay, we're going to try to find food. And we'll continue on and we'll eat food. Okay, so yeah, if we start that here. We'll load it. So hungry, false. We were not hungry yet. Okay, now we're hungry. Okay, we found it, we ate it. Great. Okay, false, false, false. We found it. Okay, here you can see we found it. But now we got an issue. Okay, it's too far away. So the agent actually can only interact with things that are within this yellow circle here. Okay. So this pancake, where he can find it, okay, he can find that pancake, but he's not going to be able to eat it because it's way too far away. So now we got to add some more functionality again. We could probably use the same subtrees that we used before, but we just got to add some functionality for moving to a node. So let's create these things again. So while I'm creating these things, one thing to think about is when we are close to a node already, or close to a pancake, we're not going to want to move to it. So we can have another fallback there that will check for that. We'll add another fallback, and we want to perform these in order too. So we want to find the food. This is going to be our find food subtree here. Okay, great. So if there's food nearby, we can continue. If not, we got to find the food. So this is the same subtree we found earlier. We're just going to add a little bit more detail here. So now, okay, we can check another thing. Okay, so if we're not nearby, so if the food is in range, we don't really have to worry. If the food is in range, we don't have to worry. We can continue on with our execution. But if it's not, we're going to want to go to food. We have a go to food action that I made. So this could be generalized as a go to X function. It could just go to some place that's set by the agent or something else. But for simplicity for this demo, I just have a script that says go to food. Okay, so now it's going to find the food first. So we got a sequence here. We want to make sure we find the food first before we try to go to it or check if it's in range. And these could probably be linked up to this sequence here. Just for readability, we can make a second sequence here. And then we can have our check like before is hungry, and then our goal state, eat food. So we'll link these up here. This sequence goes here first, and then it'll check for food and go to it, and then it'll eat food. Okay, and we can link that to our root. So perfect. Now, what he should do is, if when he's hungry, he's going to look for food, and if it's in range, he's going to eat it. If not, he's going to go to it, and he's going to eat it. Great. Let's run it, and we'll load the tree right away. He's not hungry. He's going to chill there. He is hungry. Okay, he ate it. Okay. Now he's going to wait again. Okay, he's hungry. He's decided, okay, I'm going to the food now. He's going to walk over there slowly. Okay, once he's in range, okay, he ate it again. Great. So now he's going to decide, okay, I'm still hungry. We're going to go over here. So that's exactly what we wanted from this. And so this kind of illustrated, I think, the goal of this was to illustrate the modularity of behavior trees and how we can use these subtrees in multiple ways, and we can really expand these simple behaviors like eating food. You can have one node for that, but if you add a lot more, you can really fine-grain and fine-tune that detail and get more advanced functionality. So I hope you got something out of this, and yeah, thank you for watching.